Welcome to my channel where we'll be looking at how to find a basis and the dimension of vectors. In our previous video, we looked at how to determine if vectors form a basis of a certain vector space. If a certain set, for example, a set of vectors form a basis of a vector space. So in that same video, we defined a basis and we looked at several examples. So today again, we'll now be defining a dimension of vector spaces, or dimension of a vector space, and then we'll want to look at various examples on how to determine the basis of a vector space and the dimension of a vector space. So let's first define dimension. And by dimension of vector space, we mean the number of elements in the basis of a vector space. The cardinality, the number of elements of the basis of V, that will form the dimension of V. That means if a vector space has a basis that is finite, if a vector space has a basis that is finite, then we will say that that vector space is finite dimension. That means if the dimension of the vector space is n, then the vector space will be finite dimension. So that in other words, the basis of this vector space has n elements. Now, the vector space will be said to be infinite dimensional if its basis has an infinite number of elements. So let's look at examples on how to determine the basis of a vector space. The first example here is find the basis for the vector space V that is spanned by vector R, B, and C. So there are two ways that we proceed to find the basis of a vector space. I will begin by showing the first way. And the first way, we arrange the vectors in columns and then reduce to echelon form. So my first column will be vector R, and the second column here is vector B, and then the third column is vector C. So we know how to reduce this to echelon form, and I'll just remind you what we used to do to reduce to echelon form, but we already know how to do that. We already have a 0 in this position, and that is very okay. So I want a 0 in this other position. So to get a 0 in this position, I'll take row 3 minus row 1 to give my new row 3. So that's what I did. So 1 from 1, I have a 0 here, and 2 from -1, I have -3, and then -1 from 2, I have 3. So I have a 0 in this position and this position. So the next thing I want is a 0 in this position. So I would take row 3 plus 3/2 of row 2. And this will give me my new row 3. So that means the final matrix I would have, the first row remains where it is. The second row, what I did here, first of all, I divided this by 2. But it's not a must. You can just work with what I have here. You can work with what I have here. But I divided this by 2. So you see, when we divide it by 2, what you would have, instead of the next matrix here, that I would have would be the first row remains where it is, and then the second row I divide by 2 would be 1, and then negative 1, and then this will be 0, negative 3, and 3. So this one, you see, making this one 1 makes my work easier. It makes our work easier. So let's see how that works. So let me now do this and say that now from this I come to this and I want this to be 0. So what I did was I took row 3 plus 3 row 2 to give my new row 3. So you can see that the first row remains where it is, the second row remains where it is, and then to obtain this times 3 plus this gives me 0, and this times 3 plus this gives me 0. So I have this. This is what I end up as the final matrix in echelon form. So what was the question? The question was I wanted the basis for the vectors. So I go for the leading ones. I have this leading one and this leading one. This leading one is in column 1, and this leading one is in column 2. You can see that column 3 has no leading one. So the leading ones are the ones that will guide me to get the basis. So I've written them that said the leading ones in each row are in column 1 and column 2. Hence, the vectors in those columns form the basis. What is the vector in column 1? The vector in column 1 was 1, 0, 1. And the vector in column 2 was 2, 2, negative 1. So that was vector A and vector B. So these two vectors, they form a basis. So this one, they are formed a basis. So that basis has how many elements? It has this element, vector A, and it has this other element, vector B, and those are two elements. And therefore, the vectors given are the basis. They form a basis of dimension 2 because we have two elements in the basis. We have two elements in the basis, so they form a basis of dimension 2. So look at what we did. What we did was we were given vectors and we decided to arrange these vectors in column form and then reduced to echelon form, and then looked at the leading ones. In which columns are the leading ones? So the leading ones, we have the leading one in column 1, the leading one in column 2. So the vectors in those two columns form the basis of these vectors. So the vector A and the vector B form a basis. And so since they form a basis, this basis has only two elements here. And therefore, the dimension of this vector space is 2. The dimension of vector space B is 2. Now, the alternative way would have been to arrange the elements in rows and then reduce to echelon form. Let's do that and see what we get. So these are vectors. I will just arrange the first vector in the first row, second vector in second row, third vector in third row, and I've reduced to echelon form to obtain this final matrix. And again, it's very important that I identify the leading ones. This leading one and this leading one. So the basis, since I had arranged my elements in rows, and this leading one is in row 1, so the vector in row 1 becomes, which was A, and also the vector in row 2, which was B. These two form a basis. These two form a basis of the vector space B. And you can still see that the dimension is 2 because that basis has 2 elements. The other way, if you arrange the vectors in rows, the other way that we would come up with a basis is that after identifying the leading ones as this one and this, and then column 1, column 2, and I've already said that the vectors in those rows, the vectors in this row form a basis. So it will be, I can take this A, vector A, and vector B to be basis. Just the same way I had explained, or alternatively, the other way I could do that, I would take this vector 1, 0, 1, and this other one 0, 1, negative 3 over 2 to form a basis. So the basis here, one can give a basis as this, or as this and this. So if I were to arrange elements in row form, there are two ways I can write the basis for this vector space. I can just take the non-zero rows. The non-zero rows become a basis, the way I've done here. This row, this row become a basis. Or I can take the original rows, the original row 1 and the original row 2 to form a basis. So we can also have the original row. Whichever way, the dimension will be the same, because if I were to choose this row and that row, then they have 2 elements. So the basis has 2 elements. And if I were to choose the original rows, still the basis would have 2 elements. So I think I should look at another example to make the knowledge of basis and the dimension clear. So this is my other example. Find a basis and dimension of this set. So I'm given this set, and this set has this vector, this other vector. How many vectors are these? 1, 2, 3, 4, 5, 6. These are vectors that are in column form. Remember, they could be given to you in row form, but these ones have been given to us in column form. So I want a basis. So I would still arrange these elements the way they are in column form. The first element as the first column, the second element, second column, the third element, third column, the fourth element, fourth column, the fifth element, fifth column, and then the fifth, sixth vector here to be the sixth column. And then reduce to echelon form. And you know how to reduce that. So when I did reduce to echelon form, what I got was this as my final matrix. Remember that these ones were arranged in column form. The vectors were arranged in column form. So we would identify the leading ones and choose the vectors in the original columns. The vectors in the original columns become the basis. So I have this leading one in first column, this leading one in second column, this leading one in third column. This fourth column has no leading one. But I have this fifth column that has a leading one. So the original vectors in those columns form the basis for this vector space. So that's what I've said, that the leading ones in each row are in columns 1, 2, 3, and 5. Thus, the vectors in column 1, original vectors, Column 1, this was this vector. Column 2 was this, column 3 was this, and column 5 was this vector. These 1, 2, 3, 4 vectors form a basis. And since there are 4, the dimension of S is 4. The dimension of S is 4. So our set was set S, that's correct. So that set S has dimension 4. Okay, let me now look at another example here. Find the basis and dimension of this span. This span has how many vectors? 1, 2, 3, 4, 5, and 6 vectors. As I've said, we can decide to write in column form. So that's what I did. That's what I did here. This vector, I put it so let me see. Find the basis and dimension of this. So which one did I arrange here? Did I arrange in column form? No. Not arrange in column form. What about? So let's just do it. Let's just do it and see. It seems this. I had already worked on it. Then what I just wrote here were the results. So let's just do it. I have 1, 0, 1, 1 as my first column. The second column will be negative 1, 1, negative 1, 0. And then this other one will be 1. With how many zeros? 1, 2, 3. 1, 2, 3. So that is the third one. 1, 2, 3. So I'm coming to the fourth one. 0, 1 with the 2 zeros. Then coming to this other one, it is 0, 0, 1, 0. So I've written this. So I'm coming to this 1, 2, 3, and then 1 here. So I reduce this to echelon form. You know that I want a 0 in this position and a 0 in this position. So what do I get? The first row remains it is 1, negative 1, 1 with 3 zeros. Then the second row remains it is 0, 1, because we already have a 0 in this position. So this will be 0, and then 1 with the 2 zeros here. And then I need a 0 in this position. I will subtract row 1 from row 3. So subtracting this from that, I'll have a 0. And subtracting this from this, I would have another 0. Subtracting this from this, I would have negative 1. Then this one remains a 0, that remains 1, that remains 0. So 0, 1, 0. Now I also want a 0 in this position. So just subtract this from that, I have a 0. Subtract this from that, I have a 1. Subtract this from this, I have negative 1. So I'm done with this. So now this is 0, this is 0, and this is 1. So 0, 0, 0, 0, 1. Now, so I can see the other leading one that I have. And that is what I got here, I think. This is what I have here. That's what I have here. So the problem here was that this one was supposed to be 1. And this one was supposed to be negative 1, 1, negative 1. This was to be 1, which is 0. This was to be 0, 1, Yeah, so the problem was only here. Now, so this is what I have. Not exactly because I have a 0 here. So what I did was I now have this leading one. I want a 0 here and another 0 here. So fortunately, we already have a 0 here. So we only need to create a 0 here. Okay. So let me see what I have. The first row remains where it is. The second row remains where it is. And then to get the third row remains where it is because we already have a 0 here. So I would have a negative positive 1. So let me just write there will be a positive 1. No, negative 1, 0, negative 1, 0, 1, and that. So this is where I have a problem. I need a 0 here. So I need only to subtract this row from this row. So when you subtract this row from this row, 1 from this, it will give us 0 here. It will become a 0. Then 0 from negative 1, I will mark the negative 1. Then 1 from 0, I would have negative 1. I would have negative 1 in this position. I would have negative 1 because it was 0. It was 1 from 0. I would have negative 1. And then this was 0. This was 0. But you already know to write in echelon form. I'm just repeating what you already know. Now, so you look at this element and this. I need a leading one in this position. So I would multiply this row by negative 1. And so what do I get? Divided by negative 1, this would be positive 1. And this would be negative 1. And now use this one, this leading one, to create a 0 in this position. That is what gives me the final matrix, because what I wrote here was a final matrix. What I wrote here was a final matrix for reducing to echelon form. So look at the first row. It remains where it is. The second row remains where it is. The third row is 0, 0, 1, 0, negative 1. Is it supposed to be negative 1 or positive 1? Yeah, you try and go through slowly and see what you get. Now, so what about here? Make a 0 here. So just add this. You have a 0. Add this. It's supposed to be negative 1, obviously. So you go through here and see what you get. I think during the calculation here, since they are squeezed, it must have missed something. But let's suppose this is the final matrix that I get. Let's suppose this is the final matrix. What I'm interested in is the basis. But we'll go through slowly and see. So to get the basis, since these vectors were arranged in column form, I would choose the leading ones. You have a leading one in the first column, the leading one in the second column, the leading one in third column, then the other leading one that I have is in 1, 2, 3, 4, 5, 6th column. It's in the 6th column. So the original vectors in column 1, column 2, column 3, and column 6 form the basis. So let's see. So what did I say? What I say is that the leading ones in each row are in column 1, column 2. column 3 and column 6. Hence, the original vectors in those columns form the basis. That is, the basis will be this set. The basis will be this set. And what is the dimension? The dimension of this vector space will be the number of elements in this set. 1, 2, 3, 4. So that is dimension 4. But as I said, I really doubt this result. What I want you to do, because of time, arrange these elements in column form and reduce them to echelon, because you already know how to do that. And from there, use our knowledge of finding the basis to find the basis for this vector space. Okay, let's look at this example. Find a basis for R5 that contains these two vectors. Find a basis for R5 that contains this vector and this vector. Now we must be knowing the natural basis for R5. The natural basis for R5 is this vector, this other vector, this other vector, this other vector, and this other vector. So this is a natural basis. We have 1 with 4 zeros, then 0, 1 with 3 zeros, then 0, 0, 1 with 3 zeros, then 3 zeros, 1 with a 0, then 4 zeros with a 1. So this is a natural basis for R5. Now, what does the question want? The question wants us to find the basis for R5. And that basis must contain these two vectors. So I just added these two vectors to these other 5 vectors, 1, 2, 3, 4, 5, and formed a column matrix. So I began with the vectors that I'm being asked to. The first vector here was 1, 1, 0, 1, 0. So I put it in the first column. You can see there. Then the second vector that our basis must contain is negative 1, negative 1, 0, negative 1, 0. And so I put that in our second column. And then I put these other vectors in the other columns. This one in the third column, this in the fourth column, this in the fifth, and so on. Then reduce this matrix to echelon form. When I did that, when I reduced this matrix to echelon form, this is what I got as my final matrix. Remember that these vectors had been arranged in columns, and the leading ones are this is a leading one in column 1. The other leading one here is in column 3. So I'm taking the original vectors in those columns. This is column 2, column 3, column 4 has no leading one, column 5 has a leading one. Column 6 has a leading one. And then column 7 has a leading one. So the original vectors, this vector, this, and this, and that, they form a basis for R5. They form a basis for R5. And you can see we have answered the question. That we needed a basis that will contain those two vectors. So let's see what my solution was. My solution was that the vector in column 1, those vectors that I had ticked, column 1, column 3, you can see it, and then this other column, where we have the leading ones, column 3, it's here, 1, 0, 0. Then the leading one in this other column third last column, 1, 2, 3, 0, 0, 1, this. And then you have a leading one in the second last column, this vector. And then you have a leading one in the last column, this vector. These will form a basis. And how many are they? 1, 2, 3, 4, 5 elements. And so the dimension of this basis is 5. And that is how we've determined the basis of a vector space and the dimension. Remember that the dimension will be the number of elements